Let me explain how to set values for AC parametric analysis on this exemplary circuit. The problem is to size the capacitor for power factor correction such that power factor of the load is unity. So our load is of inductive character, and we connect the power capacitor here, and our task is to find its value such that power factor of the whole load is unity. We have to create a circuit at first using a net part browser and draw line, draw wire. Then we have to set values of circuit parts, of all circuits parts, including variable capacitance. This variable capacitance simply set this value as C var in brackets, like here. Okay, it is not enough. We also have to get a parameter part from a browser, from this browser, and then we have double click on this part, which is not part of the circuit, but it is part of analysis. So it is beside our circuit diagram. We have a parameter. We double click on this, and we have to set the name, which is C variable without brackets, and value, which is arbitrary value. 1 micro, doesn't matter what is the value. Okay, we are ready for the simulation, but before we start the simulation we have to set analysis setup. AC sweep has to be selected, 1 point, and same frequency start and end frequency of 50 Hz. Then we have to set a parameter, parametric analysis data. So the name of parameters is C var. We may select decade sweep type, and then 3 values start and then points per decade. These values, it is a matter of experience, and I'm not going to discuss why these, not the other ones. Okay, so we are nearly ready to start simulation. We have to save this file, and then we have to click simulate, and when completed we have to select all, and we are ready to display the results in probe window. We also may examine our netlist, and below we have the netlist. At first we have a black probe window, then we have to add plots, and we have to add traces. We know that this condition, when this power factor is unity, this current that flows to the load reaches its minimum, and there is no phase shift between this current and this voltage. So we may examine any of these two plots, current or phase shift. Above we have a current, and at the minimum, cursor minimum, we have the value of capacitance, and at the, which is here, the netlist is repeated down there, and for these below trace we have a phase shift. When we search for the level of 0, we obtain exactly the same value. Now a live version of all these settings. So I'm going to press this link, okay, and my circuit diagram already stored in computer memory appears. We have set here the value of this variable capacitance is C var in brackets, and parameter, I'm going to double click, parameter, its name is C var without brackets, and value arbitrary number. What regards analysis setup, AC sweep with only one frequency of 50 Hz, and one parameter, its name is C var, global parameter, sweep type and decade selected, and these 3 values selected then. Okay, these data have to be stored in computer memory, and then we may start a simulation. Simulation has been started now, and we select all parameters. The black probe window appears. We have already C var on the horizontal axis. The first trace that we may add is a phase shift between voltage, capacitor voltage, and capacitor current. Okay, so this is a phase shift between capacitor voltage and capacitor current. when power factor is corrected to unity, then obviously this phase shift is 0. So we are here. To read exactly this value, it is recommended to use toggle cursor and then search forward. Search commands, search forward. Level 0. Okay, this is the value. We may read this value, which is 159 micro. We may add another plot to this window, add plot, and this plot now is trace, add trace is a current that flows through our load, sorry. Okay, and our minimum designates this capacitance, which is obviously the same, 159. Using toggle cursor and find minimum, we may find this value, exactly the same value as before. Okay, that way we have completed calculations for this exemplary circuit.